Hello, today I'm going to show you these cool little ultrasonic sensors that you can get. I have them on my site. Lots of people are selling them now. They're remarkably affordable. Most people just sell it just like this. The only thing I do differently is I do actually bundle it with some wires and some adapter pieces so you can use it right out of the box. You don't have to go digging around in your bins trying to make all kinds of cables and other things like that. If we look at it carefully, you can see it does have two transducers on it. One of them is labeled T, which is the transmitter. One of them's R, the receiver. Okay, so it sends out a pulse out of the transmitter. That pulse goes and bounces off an object, and then it echoes back, and it measures the amount of time it takes to echo back. All right, and if we look at it in a data sheet, you can see how it works here. The trigger is the pin that's going to tell it to send out the pulse. So when the trigger sends a high signal, it ends up that the device then sends out a 40 kilohertz burst of sound, okay? A little sonic ping. And then what it does is it listens for the echo, okay? And that echo comes at different times depending on the distance from the wall. You could try it yourself. Yell at a wall. If you're standing close to it, the echo is almost so fast it's imperceptible. Get further away, the echo is longer. Go to the Grand Canyon, it's really long. Okay? Those time, the speed of sound is a known entity. We can calculate it with all sorts of variables. But basically, assuming you're at ground level and everything else, we can use these formulas here to be able to convert that time from the burst to the echo to give us a number that corresponds in inches and centimeters that the object is distanced away. Okay? And if we look carefully at our ultrasonic here, get it so it autofocuses, there we go. You can see there are 4 pins, VCC, which is going to be the positive, ground, of course, which is going to be the ground, and there's the trigger and the echo. Okay, the cable that I like to use has got a 4-position female on it. The colors may change, so don't count on it being black, white, gray, and purple. That could be any one of a number of colors. I'm going to plug the black into ground. It makes logical sense. And in this case, so the purple then becomes my positive. You can see that they're crisscrossed so that the black and the purple end up coming into a 2-position hood. You can do whatever you want. And then I have my trigger and my echo going into another 2-position hood. Alright, and I'm going to be using this on a breadboard, and I think you would do this if you were doing it on an Arduino Uno as well with the female socket. So now I'm going to change it over so it'll plug into the female. And let me set up a little robot here. It's a breadboard system. Okay. On this particular robot, there's a 7805 as a voltage regulator, for those of you who don't know. And this is going to be, this particular side is going to be a 5-volt supply closest to the red bus, and ground, of course, closest to the blue bus. I'm going to turn off autofocus. Just give me a moment so I can make it manually focus, because we won't move it again. There we go. So therefore, if I plug my ultrasonic in, I'm going to take the ground wire, plug it closest to the blue bus. In case the purple wire, my case, is the one that goes up to the VCC of this board. And then I'm going to choose any 2 available pins to plug in my trigger and echo. In this case, the white wire is the echo, okay, which then means that on this Teensy, that's going to be 0, 1, 2, 3. Pin 4 is going to be my echo, and pin 5 is going to be my trigger. All right. So, how to make it work? I've taken a lot of the work out of it for you. I've wrote a library. Of course, you can get other ones too. And the library can be located here. If you go to the page where I actually have the ultrasonic sensor and cables, and you click on the highlighted link here, it will open up another page, which is the zip file. Okay, and you can go ahead and download that zip file onto wherever it is you put it, probably in your download section. And we can get rid of that for the moment. And if you haven't done it before, there's so many ways, but I've already done it on this application. But to install a library, go to the include library, and here scroll up to add zip library, and from there, as soon as it opens up the window, you would choose the zip file. Okay, and what will happen is it'll automatically unzip it and install it all into the proper locations. And if it does that, you'll have, come on, my computer's running really slow, there we go, you'll have a library edition right here, the HC-SR04. Alright, now to get you started, you can simply go to examples and then scroll down to the HC-SR04 and click on example, and it'll open up this example. Okay, so let's minimize that, and I should plug my robot in. I'll move it over here so you can kind of see what I'm doing. Alright, plug in my little bread bot. Okay. So, what did I say? I said that I had my echo on pin 4 and my trigger on pin 5. So if I go down here, you can see that I've called it, in this particular case, the library is here. It's now been included in this example file. For anything you're going to do, you have to include this particular section into your code as well. This creates the object. Okay, I called it Echo 1 in this example. You can call it anything you want. Echo 1 is just the name I chose. But I do have to tell it which pins it is connected to. Okay, the echo pin, the white wire, is hooked up to pin 4, and the trigger is hooked up to pin 5, echo and trigger. Okay, from there, actually, believe it or not, this example will just simply work. I'm certainly hoping. I'm going to go down here and make sure it's selected. Everything looks good, and I'm going to upload it. And as soon as it builds and uploads, I will show it to you working. Okay, and if I open up the serial window, and let's see if I can put this in a position that you can kind of see. Here's, let me move a couple of things out of the way. Alright, so here I've got my ultrasonic. You can see the data down there, and although we don't have a lot of space, if I put my hand here, it does in fact, I'm going to angle it up so you can see 6 inches, 7 inches. You can't see my hand, but you can see the shadow, and it's working quite well. Alright, oops, that was a little bit of it. My hand moved out of the way. There we go. So it works remarkably well. Now, I can use this piece of data here. Let me actually close this window out and open up this. Alright, and let me show you this particular board actually has another ultrasonic just hanging there, because what I'm going to do is I'm going to unplug this one, and I'm going to carefully plug it in to here. Okay, and in fact, I think what I'm going to do is I'm going to open up Yep, it's still working great. Although why? Oh, sorry. Got to aim that better. There we go. There we go. Sorry about that. So it's working just fine. Now what I'm going to do is I'm going to actually make a decision on some of this data. Okay, so hold on a second and I will set that up. Okay, so let's wrap this up. So you can see I've included the library. I've defined the pins. Okay. The other thing I've thrown on here, you can see it. I've got this tricolor LED that I've kind of rearranged and dragged out to the front. It's hooked up to pins 10, 11, and 12. LED 1, 2, and 3. So I think it was red, green, blue. I opened up a serial window, and of course I told the pin to be output so I could light up those LEDs. Alright, and then I go to my loop. Remember my object, my ultrasonic object I called echo 1. Okay, if I say echo 1 dot read inches, read echo inches, it's going to collect the data in inches, and it's going to automatically save it into a variable already created in the library called echo1.inches. Okay, again, if I change that to echo 2 or Snickeldorf, it doesn't matter. I can name it anything I want, but it'll be Snickeldorf.inches. Okay, is going to be where that information is kept. Here I've wrote a real simple program. If echo1.inches is greater than 8, you're going to light the third LED, which is blue. Okay, and in this case, if echo1.inches is less than 7 and it's greater than 4, then let's light up the green LED. So if I move this out of the way, you can see that currently it is greater than 8. And if I put this in here, I can move it around. It falls within the parameter. It shifts it to green. Okay? So it does a great job of measuring distance, and it fits the program. So hopefully that's enough to get you guys started, and I'll post another video here not too long, a little more complex, of how to actually integrate this into robot motion. And I will hopefully see you later. Bye.